what if everything we know about the universe is wrong? What if black holes aren't what we think they are? And what's hiding inside them could rewrite the laws of physics themselves. For centuries, scientists have believed that space follows predictable rules, that every galaxy, every star, every atom plays by the same script. But new theories are tearing those rules apart. There are stars that might not even be made of matter objects that could push the universe apart instead of pulling it together. And maybe, just maybe, worlds where another version of you is watching this same video right now. These aren't science fiction ideas. They're real theories debated by actual astrophysicists. And if even one of them turns out to be true reality as we know, it will never look the same again. Let's start with the one that could expose every black hole in the universe as a cosmic lie. Imagine something that looks exactly like a black hole, same size, same darkness, same terrifying gravity, but isn't one at all. This is the gravastar, or gravitational vacuum star, and it's one of the strangest ideas in modern astrophysics. Scientists believe that instead of a bottomless pit swallowing everything forever, a gravastar could be a hollow bubble of energy, a star made of nothing. Inside it, there's no crushing gravity, no swirling chaos. It's pure balance. Positive energy pulling in, negative pressure pushing out. In theory, those two forces cancel perfectly, creating a shell so dense that even light can barely escape. To an astronomer's eye, it would look like a black hole. But it isn't. That means every black hole we've ever spotted, every monstrous void at the center of a galaxy, could actually be one of these vacuum stars. And if that's true, it changes everything. Because instead of devouring the universe, gravastars might be powering it. They could even explain dark energy, that invisible force pushing galaxies apart faster and faster. If gravastars really exist, they might not just mimic black holes. They might be the source of the universe's expansion itself. But what if space doesn't just trap light? What if it can spit it back out? If black holes are cosmic traps, devouring everything that crosses their path, then white holes are their complete opposite. Imagine a celestial object so extreme that nothing can enter it. Matter, light, even time itself, all of it gets blasted outward. A white hole doesn't pull you in, it throws you out. The math behind Einstein's equations actually predicts that for every black hole that could ever exist, there could also be a mirror version, a white hole, sitting on the other end of space-time. Think of it like the universe's recycling system. One side eats, the other side spits everything back out somewhere else. Some physicists even believe the Big Bang itself might have been the explosion of an enormous white hole. The entire universe could have been ejected from a collapsed star in another reality. Meaning the thing that created everything might just be another side of the same coin. The catch? We've never seen one. If they do exist, they'd only last a fraction of a second before collapsing, or connecting to something far more mysterious. Because if black holes and white holes can exist in the same equation, that means space itself could have shortcuts, tunnels between realities hiding in plain sight. Picture this. Somewhere out there in deep space, 2 points could be connected by an invisible tunnel, a cosmic backdoor through reality itself. Step into one side, and you could emerge light years away in an instant. That's the mind-bending concept of a wormhole. Einstein and Rosen first described them as bridges through space-time, mathematical passages that could link distant galaxies or even different universes. The equations work, but the problem is keeping them open. Every model we've built so far collapses faster than light can travel through it. Unless, of course, there's something holding it apart, something exotic that bends gravity the wrong way. Some scientists suggest that negative energy matter or dark energy itself might stabilize a wormhole, keeping that tunnel wide enough for light, or even a spacecraft, to pass. If that's true, wormholes wouldn't just connect places. They could connect realities. Imagine falling into a black hole, only to be hurled out through a white hole in another galaxy, or another universe. The math says it's possible, but the universe hasn't yet shown us proof. Still, there are strange gravitational signals that hint something might be warping spacetime more violently than we understand. And if wormholes really do link universes, it raises a haunting question. How many universes are there? And could one of them be almost identical to ours? Every decision you've ever made, every yes, every no, every what if, could exist somewhere out there. Not as imagination, but as another universe. This is the multiverse theory, and it's one of the most mind-bending ideas in modern physics. It suggests that our universe might not be the only one. Instead, it's part of an endless collection of realities, each one with its own laws of physics, its own galaxies, and maybe its own version of you. It started with a problem. Scientists couldn't explain why the universe's dark energy, that invisible force pushing galaxies apart, was so perfectly balanced for life. If it were even slightly stronger, stars could never form. Slightly weaker, and the universe would collapse before life began. The odds were astronomically low, unless there were countless universes, each rolling a different set of cosmic dice. In most of them, life never had a chance. But in this one, our one, the numbers just happened to align. That's why we're here to ask the question at all. And this idea goes deeper. Some physicists say that every time a quantum particle makes a choice, reality splits, creating a new universe for every possible outcome. Millions of versions of you, branching off with every heartbeat. It sounds impossible, but the equations behind quantum mechanics don't forbid it. In fact, they might require it. But if the multiverse is real, it raises an even darker mystery. What exactly is holding all of these universes together? For decades, scientists believed dark energy was just an invisible force, something woven into the fabric of space itself. But what if it isn't spread everywhere? What if it's concentrated, hidden inside stars we can't see? That's the theory behind dark energy stars, a radical idea that suggests the universe's mysterious expansion might be powered by objects masquerading as black holes. In early 2023, a team of physicists at the University of Hawaii noticed something strange. The black holes they were studying seemed to be gaining mass over time, and at exactly the same rate the universe's dark energy was increasing. Coincidence? Maybe not. If those black holes weren't truly black holes but rather dark energy stars, vast, dense spheres filled with vacuum energy, it could explain why the cosmos keeps stretching faster and faster. Instead of collapsing inward, these stars could be pushing outward, inflating space itself from the inside out. That would mean dark energy isn't just some mysterious background force. It's alive, pulsing inside the most extreme objects in the universe. And if dark energy stars exist, they might be the key to understanding everything from galaxy formation to the ultimate fate of reality itself. But not all stars are so peaceful. Some are so unstable, so alien, that they could destroy everything they touch, including our planet. Deep in the wreckage of dead suns, where gravity crushes atoms beyond recognition, something even stranger might form: a strange matter star. These stars are theorized to be made entirely of quarks, the tiny building blocks that make up protons and neutrons. Under the crushing pressure of a collapsing star, those quarks could fuse into a new kind of ultra-dense material called strange matter. It's heavier than anything we know, and if it ever touched ordinary matter, it could turn that matter into more of itself. That means if even a single piece of strange matter landed on Earth, it might start converting the planet atom by atom, until nothing recognizable remained. Scientists call this the Strangelet apocalypse. Fortunately, it's still just theory, but a terrifyingly solid one. No telescope has ever spotted a strange matter star, but researchers believe some neutron stars could secretly be made of it. To us, they'd look the same: small, dim, and impossibly dense. But inside, they'd be something the universe has never revealed before. And if stars this strange can exist, then what about everything else we see around us? What if the weirdest truth of all isn't out there in the cosmos, but built into reality itself? What if we're not exploring the universe, but trapped inside it? The simulation hypothesis suggests that reality itself could be an illusion, a kind of cosmic software designed by something far beyond us. Every atom, every law of physics, every galaxy, all just lines of code running on an unimaginable computer. First, it sounds absurd, but the deeper scientists look into physics, the stranger things get. The universe runs on perfect mathematics, its smallest units behaving like bits of information, switching between states like a quantum binary code. Some researchers, like Oxford's Nick Bostrom, argue that if a civilization ever became advanced enough to simulate reality, it probably already has. And statistically, that means we're more likely to be inside a simulation than in the real universe. Even quantum mechanics seems to whisper the same idea. Particles don't exist until they're observed, as if the universe is rendering reality only when someone's watching, like a cosmic video game optimizing for processing power. If that's true, black holes could be more than physical phenomena. They might be the limits of the program, the edges of simulation space, where the rules begin to break down. It's a terrifying and fascinating thought. Everything you see, every star, every galaxy, might not be real, but the story written in someone else's code. And yet, if that's the case, what happens when the simulation decides to end? So after all this gravastars, white holes, wormholes, multiverses, dark energy stars, strange matter, and the possibility that reality itself is simulated, one thing becomes clear. The universe doesn't just stretch across space. It stretches across imagination.